Everyone, welcome back to our machine learning class. So we've already seen the hands-on or the theory of logistic regression. So today we are going to do the hands-on on logistic regression, and essentially we are going to use the same framework. So we'll use the Kaggle notebook. The public notebook will be shared in your video description. So it is more or less structured the same way as we have done other notebooks. So we'll start by importing the libraries, we'll import and inspect the data, we'll set up the input and output variable, we'll feed the logistic regression model, and finally we'll evaluate the model. Okay, so just a quick refresher. If you remember that, we discussed why we cannot use linear regression for classification, and then we discussed that actually in logistic function what we find out is we find out the probability of y equal to 1 given different values of x. So that's what we find out, and then we use a technique called as maximum likelihood estimate for finding parameters of the logistic regression function. Okay, so that's an overall gist. And logistic function is a S-shaped function, so basically it can stand well for probability. So it turns out that for a value of x equal to 0, it is somewhere 0.5, and as it goes to the negative side it is very close to 0, and as it goes to very high it becomes close to 1. Okay, so this suits well to model probability. Okay, so let's start by importing the libraries. So these are your usual libraries that we import. Okay, so now let's go and import and inspect the data. So this is the same data set that we are using. Here's the breast cancer data set. So let's check out its shape and few top rows. So you'll see that it has got 569 rows and 33 columns. Okay, so if we look at the head, we see an ID column which will not be essential uh, for our study. The second thing is your diagnosis column. So basically, diagnosis is the target variable, and other variables are used to find about them. Okay, so if you go towards the end, you will see that there is a variable called as unnamed 32. You can see the values are not a number, so probably that will be one variable which is not usable. So let's now go and fit the model. So basically we'll take, starting from the first column we are not going to take, right? So we are going to take the third column to the 32nd column, right? So index starts from 0. So basically we'll say I will go from 2 to 32, right? As you remember, Python range is not inclusive, so it will take column number second to column number 31. Okay, now this is in second column, as it is 0 index, we'll give the index as 1. So our x and y are set up now. Okay, so now let's go ahead and fit the logistic regression model. So basically we start by doing our usual trend test split. Then we are taking logistic regression from a scale-learned linear model. We are initializing the log model. Okay, so let's not use this now. Let's remove this max iter. Let's use it by default. Let's run it and feed the data. Okay, so it says something. It says that total number of iteration reach limit. So basically it is saying that it has failed to converge. Okay, so what do you mean by fail to converge? So basically if you fail to converge, that means the whatever criteria was there within that iteration, it is not generating enough loss. So nevertheless, let's use this model and let's run this model. So basically what we have done is, we instead of using this direct predict function, we have used something called as predict probability, and we have taken different values. So if you remember, it used to find out the value of probability of y equal to 1 given given the different values of x, and it gives a probability, so where it will take it as 1 or where it will take it as 0. So basically what we have done is, we have taken wherever it is greater than 0.5, so that's the default setting, you set it to be malignant or thing like that. Okay, so let's feed this model. Okay, so let's feed this model, and you will see that you are getting certain amount of accuracies. Accuracies are not too bad. Okay, so it doesn't look bad at all. What we'll now do is we'll plot this versus the probability, the accuracy. Okay, so if I plot the accuracy, so this is how it looks like. It starts with 0.89, and then 0 point, probably at 0.6 it gives you good accuracy value, and that is how the model looks like. Now let's go ahead and change the iteration and see if there are some changes. Let's not change only to 5,000. Let's make it even bigger. That may take a little bit of time, but let's see that for such kind of data set, if there is enough effect. So let's again go ahead and run this. Okay, not much changes. So basically, even without convergence, it keeps quite similar values. Okay, uh, so but only thing is that here, if you see, even at 0.8 it is showing something of upward trend. There is little bit of difference in the behavior. Now let's go ahead and discuss some of the important parameters. So there is a parameter called as solver. By default it is LBFGS. So basically, as we have discussed in one of our last lectures in gradient descent, so basically there are different techniques, different solvers which tries to find the parameters. They have different assumptions. You can google them up. You will see that nice papers coming up to support each one of them. uh, Max iteration default value is 100. If you remember, logistic is ideally suited for binary classification, but you can change it to classification. So if you go for OVR, it is 1 versus rest, and if you set it as multinomial, then that means it is a cross entropy loss function, which will probably read more when we do neural networks. And this penalty is always for avoiding overfitting. Okay, all right. So now I will like to, yeah, so you have seen a lot of classifiers. So I would like to recommend you to go through this blog, which is called as Classifier Comparison. So it creates different kind of data and it tries to see how the decision boundary is. So this was one input data, and nearest neighbor created a decision boundary like this. SVM has created a boundary like this. RVF SVM has been quite accurate. Gaussian process has been quite accurate. Decision tree, if you remember, linear decision boundaries, right? Random forest we have not studied as yet. Neural net we have not studied. AdaBoost we'll see soon. Naive Bayes we have studied. So naive Bayes has a decision boundary like this. So this is a more complicated decision boundary. Okay, and you see how the classifiers have found the decision boundaries. So though this is done on synthetic data sets, but it is very important to look at decision boundaries and very important to compare classifiers. Okay, so that brings us to the end of this session. Thank you so much for watching, guys. Please feel free to give your questions and I will try to go through each one of them and answer. Thank you so much once again.